the question is, here's the chicken problem. The chicken problem is you've got 100 metres of fencing and you're going to build that fence near, obviously, near the house. So you've got a river. Alright, we're going to free range our chickens. Alright, so it backs onto the river. So 100 metres of fencing will allow us to basically fence off a certain area. So if we design that well, you know, we can maximise our profits. So let's say per square metre, free range chickens, you can put about 4 chickens per square metre. Because chickens aren't that big, right? So there'll be lots of them in there, but you know, these are not caged birds, so they'll have plenty of room really for chickens. And if you go to the supermarket, you know you can buy free range eggs for about $6 a dozen. True? I'm going to need you to help me out with a calculation here. What's the maximum profit we can make based on our chicken pen? Alright, so what we have to do is we have to think about how we're going to put this together. So let's work on that now. So let's say we're going to call this distance here x. Alright, that distance there is going to be x. What's this distance here going to be? If we had 100 metres of fencing, that there is x. That there is x. What's this distance here going to be? 100 metres of fencing. Isn't it going to be simply 100 take 2x? Isn't that what that thing's going to be? Depending on, like, what would be some examples we could use? We could say, if make x equal to 10, it's going to be 10 by 80, isn't it? 10 by 80 is going to be like 800 square metres. Right? If we're going to have it, say x is equal to 20, then that'll be 20 by 40, 20 by 60. If it was x was equal to 30, it'd be 30 by 40. Got the idea? So you different size particular things based on the value of x. So it's a bit of a trial and error way. That's how you would have to do this up to now to actually solve that. One of the things I can do say though is the area of my particular thing is going to be simply the x value by the 100 take 2x. Agree? And then I can say that's equal to, obviously if I times 100 through, that's going to be 100x take 2x squared. Agreed? So if we tried some x values, x equals, say 10, right, then that's going to be the area. We can either substitute it straight into there or we can go 10 times by 10 times by 80, and that's going to give you 800 metres squared. Obviously the area of x is equal to 20, as we said before. It's going to be 100 take 2 lots of 20, so that will be 60, so that's going to be equal to 1200 metres squared. Maybe the solution's not a whole number. Maybe it's a the best solution might be a between two numbers, wouldn't it? So we could use our graphics calculator to do that as well. The easiest way to do it though is to use our graphics calculator and do the following. Alright, so if I just bring up my graphics calculator. And the thing about graphics calculator, this is why you need one, is you can graph these things. Okay, so if I just clear my screen here, right, I'm going to go to my y equals, and I'm going to plot this graph. I'm going to plot a graph of, what was it? It was 100x, x, take away 2x squared. And I'm going to just graph that, and I'm not seeing anything there. The reason why I'm not seeing anything is because my scale's not right. Remember the graphing area? What did that area get up to? Like the two calculations we just did then. What was the maximum area? About 1200. So it might go up to 1500, 1600 if we get it right. What's the maximum x could be? If we've got 100 metres of fencing, what would be the maximum x could be? Probably 100 metres, wouldn't it? No, it wouldn't actually give you an area if it was 100 metres. It'd be a long fence along the river. You just fenced off the river. wouldn't be able to get too many chickens in there, they'd all drown. Alright, so if we set our min to be, say, minus 10, let's make our max to be 110. This is our x coordinate, and then we can set our y max to be maybe 2000. Right, and enter, and we graph that now. Hopefully we'll see a curve. Aha! And that shows us all of our possible solutions that we can actually have here. Does that make sense? All our possible solutions. How do we find this point here at the top? Well, you could use your trace button. The trace button allows you to just scroll through, tells you your x coordinate and your y coordinate. That's one way of doing it. So it's roughly, this looks like it's about 1250, doesn't it? At a guess. Right. The way you can do this accurately though is to go and use your calc button on your calculator. So calc, and we come down to our maximum value, that's what we're looking for, so press number 4. We go to the left hand side of the maximum value and we go enter. We go to the right hand side of the maximum value and we go enter, and then we press enter again, and it tells us what our value is. So when x is equal to 25, the maximum we're going to get is 1255. Okay, so using our quadratics, using our function, that's a really quick way of doing it. So max when x is equal to 25, so that makes the other side basically this y value, makes our y value equal to 50, doesn't it? And so the area is going to be equal to 1,250 square metres. Right, let's do a quick comparison now for our chickens. I need you to get your calculators out to help me here. Alright, so how many chickens, let's call this pen number 1 over here, and our maximum pen number 2. Alright, so let's do number 1 calculations. We've got an area of 800 square metres. Alright, so how many chickens can we get into our pen over? How many free range chickens? So the number of chickens is going to be equal to the area times by 4, isn't it? So we're going to get how many chickens? 3,200 chickens. Alright, for number 2 though, the number of chickens that we're going to be able to get in there, chickens is going to be equal to what? 1250 times by 4, so that's going to be 4,000, it's going to be 5,000 chickens. Okay, get the idea? Working at the number of chickens? Alright, let's say every chicken lays an egg every day. That's what we roughly do, don't we? A chicken a day. So every day, you're going to get 3,200 eggs. And over here, you're going to get 5,000 eggs. Alright, so if we divide that by 12, and then times that by 6, that will tell us how much money, dollars per day. Can someone do that calculation for us? Using my math skills, it's $1,600 a day. Okay, over here, we're going to divide that by 12 times by 6, so it's really like dividing by 2. We're going to get $2,500 a day. Aren't we? Now, coming over here, the next bit, how many days in the year are we going to basically have? So can you times that value by 365? So dollars per year is how much? Because remember, chickens don't have the day off, do they? They just lay their egg every day. How much? 584,000. I should go into the chicken business, I reckon. Alright, and over here, how much are we making in a year for the 2,500 a day scenario? How much? Okay. Which chicken farmer do you want to be?
The rich one.
I want to be this one over here. Tick, 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 tick. That's the one I want to be. I want to maximise my profits just by being a little bit smarter about how I organise my pen, right? Because I've got the same materials. It just means I can get a whole lot of birds in there extra, which means that I make more money. Alright? So, you know, chicken farmer over there making nearly $1 million a year before costs, of course. There are some costs associated with that. But, you know, even if they made 50% of that, they're making a pretty handy profit just for looking after some birds and picking up some eggs. Alright? So, you get the idea that maximising the area is a really important thing to do. So what we're going to be looking at in this topic pretty well goes through the following things. We're going to be looking at curves that go like this, and we're going to be looking at curves that go like that. And we call these quadratic functions. Right? Essentially, I could teach you all the stuff that you need to know about quadratics in one lesson. We're going to spend about 5 weeks on it. Alright? The key thing that we need to know is we need to know that point down here. Does anybody know what we call that point? Or that point there, the max point or the min point? We'll call it starting with V. It's called the vertex. Alright, someone was getting it, it's awesome. That's also called the vertex. Okay, we have a line here. Okay, that line exists, which is equal to minus b over 2a. You go, what the hell is minus b over 2a? Well, our general equation for a quadratic, y equals ax squared plus bx plus c. And we go through this all in detail. You've seen that before? You saw that last year? No? The first time. Okay, well, our b value is what that value is, and our a value is that value there. And that tells us what the x coordinate for our vertex is. When you put that into the equation over here, you work out what your y coordinate is. Generally, we'll get these types of curves when x is greater than 0. We get these types of curves when x is less than 0, getting a negative value. When the a value, I say, is greater than 0 and less than 0. So essentially, our graph is going to be like that. So what would we use this for? Well, we use it for things like designing bridges. Alright, if you know about the Sydney Harbour Bridge, it's a big arc like that. So the engineer who designed that used quadratics to actually design part of the bridge. Alright, get the things over there. So one of the things that we will want to do is we'll want to know all about this equation. We want to know about working out what these coordinates are. Does anybody know what they relate to? Can I show you an example? A really simple example. If I give you something like y equals x squared plus 2x plus, actually no, I won't make it plus, I'll make it take. So I'm just making this up, so my brain's not working that well. So take 15. Alright? So remember that we would have done some things called factorization. You go x, and you go x, and you go 5, and 3 gives you 15, doesn't it? Or 15 and 1. So 5 and 3. And one of these has got to be negative, one's got to be positive, because that's positive, the big one has to be positive, and then the little one has to be negative. And so if we make y equal to 0, so if we make y equal to 0, the line along there is y equals 0. The x-axis is y equals 0. And so therefore, if we go 0 is equal to 3, x take 3, or x plus 5 equal to 0, because we have to make that equal to 0, so either that term has to be 0 or that term has to be 0. So in other words, x is going to be equal to 3, or x is going to be equal to negative 5. Do you remember doing this last year, factorisation? So what we're saying is, if we were drawing our axes down here, then to graph that, I know it goes like that because it's got a positive thing. It's got an intercept at minus 5. It's got an intercept at 3. So it goes something like this. Alright. Would anybody like to tell me what they reckon the axis of symmetry might be? So, minus 2? Negative 1. X equals negative 1. How'd you get negative 1? Yeah, it's about halfway between the two intercept points, isn't it? Remember, these things are symmetrical. So that tells me what my intercept point there is. I could easily find out what my vertice point is by putting it back into the equation. So if I put negative 1 into there, what would I get? I'd get negative 1 take 3 would be negative 4. And I'll get negative 1 plus 5 is plus 4. So therefore negative 4 times by plus 4 is going to give me negative 16. So that point there, the vertice for that is going to be negative 1, negative 16. Alright, essentially that's what we're doing. So whether we've got the equation that we have to graph and use to find a max min point, or modelling something like that, or whether we're using the equation to find the graph to find the equation, that's essentially what we're doing in this whole topic. So it's all about this curve. Right? It's all about these particular, what we call quadratics. Right? They've got to the power of x, right? And we're going to be dealing with those things there. As we saw with the chicken problem though, if you can maximise your profits by maximising how you do things, that person there is going to have nearly an extra $300,000, $350,000 to play with. That is a lot of money, just by doing the right mathematics. Can you see that's useful? Yeah? So we'll be looking at doing that. We're going to be doing a project also on this topic as well. Alright, so it will go into the fact that you can factorise or you can't factorise. Now, who is good at factorisation from last year? Not one person's put their hand up. You know what I mean by factorisation? Let me just show you. If I went like this, x plus 2, x plus 3, if we FOIL that out, remember FOIL? So you go x squared, and you go plus 3x plus 2x plus 6. So you say that's x squared plus 5x plus 6. That's FOIL, or expansion. Factorisation is taking something like x squared plus 5x plus 6 and going the other way around. Alright? So that's then going this step there and saying that's equal to x plus 2, x plus 3. Who's good at that process?
Yeah, I remember that.
Remember doing it? Okay at it? If you suck at it, it's not the end of the world, because we have technology that will help us. What I want you to understand though, when we're doing this topic is, that point there and that point there comes from the factorisation, doesn't it? Does that make sense? It comes from the factorisation, and that's what we're going to be working on with this whole topic. Alright, I'm going to leave that there, and we will basically